Hello students, welcome to today's session. So today we are going to take up one another problem in regard to the preparation of IIT Advanced 2022. So at times what is very interesting about the IIT problems is sometimes a very simple question they are going to ask, but they ask in such a way that they mix 2-3 topics together, and if you are not comfortable with any of the topic, you would stuck in the problem, just like in this problem. So identify the correct statement for the reaction in which iron pyrite is being roasted. So directly, indirectly, they are checking whether you are knowing iron pyrite, although they have given the formula, and it is to be roasted. So roasting of any species or any ore is being done in the presence of oxygen. Very simple it is. So from the point of view of the reaction, it is quite simple. Now, what else they are asking? They have asked a metallurgical reaction, and now they are going to ask they are asking nFactor of iron pyrite, oxygen, and they are also asking about the bonding aspect involved in the anion of iron pyrite. And lastly, they are asking FeS2 is commonly called as fool's gold. So they are checking the information concept as well as are you able to see it? The 2-3 topics got mixed. So as regard to the last option, this is a correct one because it's a information based. It looked like fool's gold because it gives you a golden type of a tinge, metallic golden luster it do have, FeS2, so that is why it is called as fool's gold. And a very beautiful name to fool somebody. You can use this particular ore. Anyhow, so the next thing, now we have to get into the reaction part. So as regard to the reaction part, definitely we are going to get Fe2O3 plus SO2 along with it. Now before I do the solving of this part, let me first break this out and show you the bonding aspect. Fe in this case, which is again at times people do a silly mistake in this case, that how to break this out. So this would be broken at like this: Fe2 positive plus S22 negative, just like the peroxide. We used to say, very popular word we use as a anion, peroxide ion. Similarly, you have a persulfide ion. So you can say this has to be persulfide ion. Now what is there in persulfide ion is sulfur is bonded by a single bond to the sulfur, and sulfur, just like oxygen, is having 6 electrons along with it. This also would have 6 electrons with it, and there is a 2 negative charge, and that 2 negative charge would come here. I'm just showing this as a green electron, so there is a negative charge here, there is a negative charge here, just like the peroxide ion. So let me answer this problem also. Persulfide bond, anion of persulfide, anion of FeS2 has one persulfide bond, which in a way is a correct one. Now we have to do the simple solving. Fe2S2 treated with oxygen gives you Fe2O3 plus SO2. What I did is that this iron, which had been in +2 oxidation state, definitely would go to +3 oxidation state. And this sulfur, let me show it here also. This sulfur, what is the oxidation state of this sulfur? If I would break from the bonding aspect, if I would show, if I would break it from the center, from this side, the apparent charge, it would get a 0, and this also would get a 0. And there is one negative charge on this sulfur as a actual charge, which would be said as its oxidation state. Let me speak it once again what I just have said. I said that these two are the electrons which are, and this is the negative charge they are having. So oxidation state is the apparent or actual charge which an atom do get when the atoms around it are removed theoretically. So if I would break it from the center, the apparent charge, it would get 0, this also would get 0, and the actual charge the sulfur is carrying is one negative charge, which is its oxidation state. So this is in -1 oxidation state, and this is in -2, this is +4, and this is -2. Now I always just would say it like this, that always do, because if in case you want to balance it out and you are not very having good hand on to the balancing, just go for the hit and trial method. So if I just do the hit and trial method, sulfur are 2, so I will just place 2 sulfur here. but I am seeing the iron is also 2, so I need to have iron also as 2 here. Am I right or not? So now if I have taken iron 2, the sulfur atom becomes 4. So to make it 4, so I just would do, I would place a 4 here. So just in a way, everything apart from oxygen got balanced. So iron 2, sulfur 4, iron 2, sulfur 4. So how many oxygen do I have here? 8 and 3 from here. So 11 oxygens are there. So I just would place 11 by 2, because this 2 and this 2 get cancelled. So you get 11 atoms. So that is the way it is to be done. Okay. Now the viewpoint is that now this is 2, and if I multiply entire of this equation by 2, what I shall be getting? So I shall be getting something of the way, this is one of the way of doing. You can adopt many other ways also. So 4, 11 without actually engaging any sort of, electronic arrangement. I just have balanced it out by the simple hit and trial method. Okay. Now we have to see into the fact that what they are asking. Now they are asking us nFactor of FeS2 is 11 in the reaction, and that for oxygen is 2 in the reaction. Let me check this out now and show it to you. How is it to be done? So here iron is in which oxidation state? +2, and sulfur is in -1 oxidation state. And iron happens to go to the +3 oxidation state, and sulfur goes to the +4. Now one way is, if I would just do it like this, iron +2 goes to +3. That would be possible if it loses 1 electron, and there are 2 sulfur atom. One sulfur atom is in -1 oxidation state, which happens to go to sulfur +4. So in the process it is going to lose 5 electrons. Am I right or not? Yes, I am definitely right. And there are 2 sulfur atoms which are engaging. So this is 2, and 5 into 2 becomes the 10. So in totality, if I would say what I have taken 1 mole of FeS2, which happens to go to the product side, changes to Fe3 positive and S sulfur in +4 oxidation state, and happens to give you 11 electrons as the total number of electron lost in the form of reducing agent. So I shall be saying what is nFactor for any reducing or oxidizing agent. For nFactor for reducing agent is the number of electrons per mole it is losing, and for oxidizing agent per mole it is gaining. So it has lost, if you just would say, it has lost 11 electrons. 1 mole of FeS2 during this reaction has lost 11 electrons. If it has lost 11 electrons, there must be someone who is going to take those electrons. Now if I would take this oxygen as such, if I would take O2 and would write it like this, oxygen 2 oxygen atom which is in 0 oxidation state, and what they do, when this oxygen went from 0 oxidation state to -2, in both sides it goes to the -2. So here oxygen reaches to -2 oxidation state. So what does it mean? That it has taken how many electrons? Because if you have 2 oxygen atoms in 0 oxidation state, or rather I just would write it like this, this would make you more comfortable with. If I would draw it like this, O2 from 0 oxidation, 2 oxygen atoms in 0 oxidation state goes to -2. So to make it balance, I have to place it -2, so that on both sides the oxygen atoms got balanced, and this charge balancing can be happened with the help of gaining 4 electrons. So what I am saying is 1 mole of oxygen happens to gain 4 electrons to change into -2. Let me repeat this once again for you, which is again very confusing for many. So oxygen goes to O2 negative. So what I did first is the balancing of oxygen. Oxygen got balanced. Now I have to do the charge balancing. So charge balancing can be done by 4 electrons. So this in a way shows this oxygen happens to gain 4 electrons. So the nFactor here is 4, which at times people take it as 2. It would not be 2. If I would say it like this oxygen in 0 oxidation state in a monatomic form takes 2 electron and changes to O2 negative. But this oxygen in monatomic form is not available. It is available in the form of O2. So it is going to take 4 electrons and change into 2 O2 negative. So I think I made my point clear. So here what we are going to say is oxygen as an oxidizing agent happens to take 4 electrons. And another thing is, if you just would recall this from your previous knowledge, by this time, if you are preparing for JEE Advanced, this is very must be clear to you that if the ratio of stoichiometric coefficients, now if I would write the ratio of stoichiometric coefficients is in the ratio of 4:11, ratio I am saying, then the ratio of nFactor would be the reciprocal of that. So the nFactor ratio happens to be 11:4. That do make a sense also. What does it mean? That 1 mole of this, let me write it once more for you, 1 mole of this species happens to loses 11 electrons. Now if I would have 4 moles of it, it would have lost 44 electrons. On the contrary, 1 mole of this oxygen happened to gain 4 electrons. Now, if I would have 11 moles of oxygen, it would have gained 44 electrons. Oh, perfect. It does make a sense. So I hope you understood this well. So now the nFactor of FeS2 is 11 in this reaction, perfectly right. And nFactor of oxygen, which again is a confusing one, this is a wrong one. Here it has to be 4. So the answer to this question, although the question was easy, a bit tricky, information based, so the answer would be A, C, D. And if in case you like this video, do subscribe to my channel, and this would boost up me for making more such videos. Hope to see you once again very shortly with some other question. Bye bye, take care, have a nice day.